Hello. Let us start engine mechanics question for production and industrial engineering. Two questions have appeared from here, both from statics. And incidentally, both the questions were based on Lami's theorem. One was from basic static equilibrium question, the other was from trusses, but both of them came down to Lami's theorem. Right? Let us look at the questions now. The first question over here. The question says a 30 kg smooth solid sphere. Smooth over here implies that you are going to neglect. Smooth over here implies you are going to neglect friction. 30 kg smooth solid sphere rests on two frictionless inclines as shown in the figure. Fine. The magnitude of contact force in newtons acting at point A is equal to how much? If the acceleration due to gravity is equal to 9.81 meters per second square, and you're supposed to consider both sphere and incline to be rigid. Okay. So over here, what is the value of normal force? The normal force or the contact force is equal to how much? This is the question. Very simple question. First of all, ask yourself how many forces are acting in the free body diagram of this particular sphere. The first thing I'm going to have is the weight. You're going to have weight over here. The second force is a normal force coming from here. The third force is a normal force coming from here. Right. Now, there is a concept in mechanics that whenever you're having in a coplanar system three forces which are creating equilibrium, either those three forces are supposed to be parallel to each other or those three forces are supposed to be concurrent. In this case, they are not parallel to each other. So the only thing left for them is to be concurrent, which implies that this particular normal is supposed to pass to center. Even this normal is supposed to pass from center, right? So now ask yourself that what is the angle in between these two? The angle between these two that I'm going to show you in the Lami's diagram. Let us say, first of all, I'm having over here weight of the sphere in the downward direction. Weight of the sphere in the downward direction. Then I'm having a normal. I have a normal from this surface B. So let us say I call this as NB. I call this as NB. Generally, people have this difficulty of identifying the angles in the Lami's. Okay, I'll try to make it simple for you. All of us know that this is going to be exactly 90 degrees, is it not? So imagine that this inclined surface is not inclined, it is actually horizontal. And the normal is perpendicular. Okay, so the incline is not inclined, it is horizontal, and the normal is perpendicular. Okay, now do one thing, try to make this incline now. Try to make this incline by how many degrees? By 30 degrees with respect to horizontal. If you incline this thing by 30 degrees, even this thing, this vertical normal, is also going to get inclined by 30 degrees with respect to vertical, is it not? So therefore, this angle over here is supposed to be equal to 150 degrees. This angle is 150 degrees. I hope you are following this. The second thing, I hope you are going to guess this now. I'm having a normal coming from point A. Let us say this is NA. NA. I want you to help me out with this thing. Okay. This incline is not inclined, it is horizontal, and I'm having normal vertical. Okay. Let us say this is horizontal, this is vertical. I now incline this by 60 degrees. If I incline my hand by 60 degrees, the perpendicular also is going to get inclined by 60 degrees. Is it not? So now it is getting inclined by 60 degrees with respect to vertical. That means I'm left over here with 120 degrees. I'm left over here with 120 degrees. And what is left in between these two? This is going to be 90 degrees. That's it. Once you get this, getting the answer is not big deal. Is it not? I can say now weight divided by sine of opposite angle is 90 degrees. Sine of 90 degrees is equal to, since the question is asking me only regarding NA, I am going to say NA divided by sine of the angle opposite to NA is equal to 150 degrees. 150 degrees. Now weight is equal to mg. So I can say from here Na is equal to how much? Mg. Mass is 30. So 30 into 9.81. This is mg. Multiplied to sine 150. Multiplied to sine 150 degrees. Divide by sine 90. Sine 90 all of us know is equal to 1. So there is no need of mentioning dividing by sine 90 over there. Okay. This would be the answer. Now if you calculate this in your calculators, you are going to get the value of Na comes out to be equal to 147.15 newtons. This would be the answer for your question. 147.15 newtons. Okay. Now in this question, if you have any difficulty, I believe that difficulty would only be in identifying the angles. Apart from that, there is nothing much critical about this question. Again, I'm telling you, whenever it comes to inclines and normals to the incline, if you have any difficulty in angle, start imagining that there is no incline, there is a horizontal surface and you have something which is perpendicular to it. If you tilt this horizontal by whatever angle, the vertical also is going to get tilted by same angle. This logic should be helpful in solving these kind of questions. Let us move further to the next question. This question is on a truss. Let me get out the frame and you can read the question for yourself. The question says, consider a truss system shown in the figure. The members AB, BC and CA are all rigid and form an equilateral triangle. All of them are having angles 60 with respect to each other. The contact between the roller and ground at C is frictionless. Mind you, this is actually a roller support. This is actually a roller support. Okay? If the self weight of members is neglected, this is one of the fundamental assumptions we make whenever it comes to trusses, that we neglect the self weight of each member. If the self weight of members is neglected, the force in member BC in newtons is how much? Negative sign should be used if the force is compressive and positive if the force is tensile. Very important. You might get a correct magnitude, but if you use a wrong sign, then you won't get marks for this, is it not? So sign convention is equally important. Round off to 2 decimal places. Furthermore, I want the answer in newtons, whereas the input load has been given in kilonewtons. Now this cannot get any simpler. It is one of the most simple questions that appeared in examination, right? This question is again based on equilibrium. It is based on Lami's only. I am going for method of joints, and that joint of interest for me is this particular, joint B. The joint of interest is joint B. Okay. If I look at this joint, let us say this is my joint B I'm having. Joint B I'm having. Joint B. I have over here an input load that is equal to 10 kilonewtons. Apart from that, I'm having two members. I'm assuming straight away that they are tensile members. I'll assume initially they are tensile members. There is no harm in assuming. Okay. So I'm having over here TBA, and over here TBC. I'm having TBC over here. Now think logically. This particular angle is supposed to be equal to exactly half of 60, is it not? Exactly half of 60, that is equal to 30 degrees. Likewise, this is equal to 30 degrees. And this angle over here, this entire angle over here is going to be 360 minus 60, that is equal to 300 degrees. It is equal to 300 degrees. I have three forces forming a Lami's. I can straight away start with the equation. I wish to find out member BC only. So I'll write 10 kilonewton upon sine of opposite. Sine of opposite. See, generally people have a misconception that opposite means exactly opposite, literal sense opposite. No, it is not literal sense opposite. For us, opposite actually means the angle included between the other two forces. The other two forces over here happen to be BA and BC. Angle over there is 300. So I'm going to take 300 degrees is equal to TBC upon sine of. Now, what would opposite mean? If I go in literal sense, again 300 would be opposite. That is wrong. Opposite means the angle between the other two forces. These two forces angle is equal to 30 degrees. Sine of 30 degrees. Sine of 30 degrees. From here, if you calculate the value of TBC, the value of TBC comes out to be equal to, first of all, negative 5.773 kilonewtons. 5.773 kilonewtons, let us say. This is the value. Now, but he wants the answer in newtons. Therefore, this value is supposed to be equal to minus 5773.5 newtons is the answer. This is the loading in BC, and minus sign is as important as the number you're writing over here, or probably more important, because that is something which people miss out on. Is it not? Minus sign over here is indicating that the load is compressive in nature. So these are two questions which appeared in mechanics subject from production paper. Thank you.